Today you will be solving equations with radicals or rational exponents. A radical equation is an equation that has a variable in the radicand or a variable with a rational exponent. Okay, so it's just an equation with a variable underneath the square root sign or root sign with within a rational exponent. That would be a fractional exponent. So if we look at our first type of problem, we're going to solve the square root of x plus 4 plus 6 equals 7. Our first step is to isolate a radical. Okay, so again, we're going to isolate our radical. So if we go over to isolate our radical, that means we're going to subtract 6 on both sides. And notice we have the square root of x plus 4 equals 1. Okay, now what do we do now? How are we going to get rid of the square root? Well, we're going to square both sides. Okay, so notice we're going to square both sides next. When we do so, the radical on the left side of the equation is no longer a radical. So we have x plus 4 equals 1. And then this just becomes a normal equation for us to solve. So we're going to subtract 4. We'll get x equals negative 3. And then the last thing we're going to do is we're going to check for extraneous solutions. Meaning I have to make sure that when I plug my solution into the original equation, that it is an okay response. So the square root of negative 3 plus 4 plus 6, does that give me 7? Does the square root of 1 plus 6 give me 7? And the answer to that is yes. Now I would like you to take a minute or two and try the example you tried. And hopefully you do get x equals 6. When you check for extraneous solutions, it also works. So if we look at our next type of problem, now we're going to be looking at a rational exponent problem. Notice our first step is to isolate the power. So in order to get the power completely alone, looks like we're going to divide both sides by 3. So we'll have x plus 1 to the 2/3 power equals 4. What we will do next is we will raise both sides to the reciprocal power of 2/3, which would be 3/2. And we're going to simplify. We know 2/3 times 3/2 is just to the first power, so we'll have x plus 1. Now, if we look at our thinking bubble, I know that we know this is the square root of 4 cubed. But remember when we solved for square roots, we have two possible answers. We have the positive answer and we have the negative. So we really have x plus 1 equals plus or minus, we know the square root of 4 is 2, all cubed. Okay, and now all that's left for us to do is to solve for x. X plus 1 equals plus or minus 8, and then we subtract 1 on both sides. So x equals negative 1 plus or minus 8, and we break it off into two solutions. Negative 1 plus 8 is 7, and negative 1 minus 8 is negative 9. And then we mentally check. So we know 7 plus 1 in the original is 8. 8 cubed root of 8 is 2. Squared is 4 times 3 is 12. So this one definitely works. For negative 9. Negative 9 plus 1 is negative 8. Cube root of negative 8 is negative 2. Negative 2 squared is 4 times 3 is also 12. So that one is also good. We're going to follow the same types of steps for letter B. So the first thing we're going to do is isolate the powers. So we're going to actually add 5 to both sides. Okay, so we'll have 6x plus 9 to the 1/3 equals 3. And then the reciprocal power of 1/3 is just 3. So we're going to actually cube both sides. We know 1/3 of 3 is 1, so we'll have 6x plus 9. And we don't have any roots this time, so 3 cubed is just 27. All we're going to do from this point is to solve for x. So we'll subtract 9 on both sides. 6x equals 18. And then divide by 6, x equals 3. And remember, we're going to check our work. If we check our work, 6 times 3 is 18, plus 9 to the 1/3 minus 5. Does that give me negative 2? Okay, so if we think about it, we know 18 plus 9 is 27, so it's like the cube root of 27 minus 5. Does that give me negative 2? Yes. So this is a solution. Okay, I want you to try the example you try next. Hopefully you get x equals 1. If you plug it into the original, we know 1 plus 3 is 4. 4 square rooted is 2, 2 cubed is 8, and 8 times 2 is 16, so it does work. Okay, so if we look at this next problem, what I would recommend you do is you isolate the more complex radical. So essentially you want to have a radical on either side of the equal sign. So I would add the square root of 3x plus 5 to both sides. Okay, so we'll drop down the square root of 2x minus 4. We'll drop down our equal sign, and we'll have the square root of 3x plus 5. Now we have to say, okay, how do we undo square root? Well, remember you're going to square both sides. And look, we know when we square a square root sign goes away. So 2x minus 4 should equal 3x plus 5. And now all that's left for us to do is to solve for x. I like to look at my x's positively, so I would subtract 2x on both sides and also subtract 5. So negative 9 equals x. Okay, so now remember, we still have to check for those extraneous solutions. If I plug into the original problem, notice we'll have negative 18 minus 4 minus the square root of negative 27 plus 5. Does that give me 0? Can you take a negative square root? And the answer to that is no. So this means no solution. Same thing with b. We're going to ask ourselves, okay, which is the scarier looking radical? Well, square root of 5 minus x looks more intense than the square root of x. So I would add the square root of x to both sides. Okay, so we'll drop down the square root of 5 minus x. We'll drop down the equal, drop down the 1, and plus the square root of x. And now we say, okay, what is, how do we get rid of square root? Remember, you're going to square both sides. But when I square the right side, the square root sign just doesn't go away. Remember, that means I have to distribute, meaning I have to FOIL. So I have to do 1 plus the square root of x times 1 plus the square root of x and FOIL. So 5 minus x equals 1 plus square root x plus square root x. And the square root of x times the square root of x is just x. Or 5 minus x equals 1 plus 2 square root x plus x. Well, do you see how we still have a radical in our problem? So we are going to isolate that radical again. Okay, so first thing we're going to do is I'm going to combine like terms on the right hand side. And I'm going to subtract 2. So we'll have 3 minus x equals 2 square root of x. Okay. Oops, I made a boo-boo. Apparently, this is not 1. That should be an x. Dope. So I have to go in and clean this up. I apologize. How come that won't erase? I want it to erase. Okay, so this is 1, so we'll subtract 1, and this is plus x, subtract x, subtract x, subtract 1. Okay, so this is 4 minus 2x equals 2 square root of x. We'll divide by 2. Okay. And notice we'll have 2 minus x equals the square root of x, and we'll square both sides. However, remember, when you square the left side, it's like you're doing 2 minus x times 2 minus x, and the right side is just x. Oh my goodness, I'm already tired. And now we distribute again. So 4 minus 2x plus x squared equals x. And remember, we have to move everything to one side. So 4 minus 5x plus x squared equals 0. And just like last semester, we are going to factor. So factors of 4 that give me negative 5, and the signs have to be the same because the sign of the 4 is the same. So 1 minus x and 4 minus x. That means we'll have x equals 1 and x equals 4. Now, remember we have to check it into the original. So if my original is 4x equals 1, that is the square root of 5 minus 1 minus the square root of 1. Does that give me 1? Okay, so square root of 4 minus 1, does that give me 1? Yes, so 1 definitely works. And if we check the other problem, x equals 4, does the square root of 4 minus 1 minus the square root of 4 give me 1 whole? Okay, the square root of 3 minus 2, does that give me 1? Oh, sorry, I messed up. Sorry, the square root of 5 minus 4, which is the square root of 1. Minus 2, does that give me 1? No, it gives me negative 1. So x equals 4 is not a solution. I want you to take a minute or two and try the example you try. Hopefully for this problem, you found that x equals 9. Okay, so in this next problem with the rational exponent, you're going to do the same sort of thinking. So the first thing you're going to do is isolate the scalar power. I would probably add the negative 1 to the other side. So you're going to actually add 28 minus 2x to the 1/4 to both sides. Okay? So we'll have x minus 2 to the 1/2 equals 28 minus 2x to the 1/4. Now this one is tricky because most students at this point say they want to square. But if I square both sides, I'm still going to have a 1/2 power on the right-hand side because 1/4 times 2 is 1/2. So what we're really going to do is whichever denominator is greater, that is the power you're going to do to both sides. So I'm actually going to 4th power both sides. So the left side becomes x minus 2 squared, and the right side is just 28 minus 2x. Now, remember x minus 2 squared? I'm thinking x minus 2 times x minus 2, which is x squared minus 4x plus 4. And then it becomes a quadratic for us to solve. So we're going to add 2x to both sides and subtract 28. Okay, so x squared minus 2x minus 24 equals 0. So now I'm going to ask myself, okay, factors of negative 24 that add to give me negative 2. Well, those would be negative 6 and positive 4. We get x equals 6 and x equals negative 4. Now remember, just like we did with the other problems, we have to do a check. 6 minus 2 to the 1/2 minus 28 minus 12 times 6 is 12 to the 1/4. Does that give me 0? Meaning, does 4 to the 1/2 power minus 28 minus 12 is 16 to the 1/4 power give me 0? 2 minus 2 equals 0, smiley. So I know x equals 6 is the solution. But what about the other? Okay, is negative 4 minus 2 to the 1/2 power minus 28 minus positive 8 to the 1/4 power give us 0. Okay, so if we have negative 6 to the 1/2 minus 28 plus 8 is 36 to the 1/4 equals 0. Now, the question becomes, can we do -6 to the 1/2 and get a number answer? And the answer to that is no. So -4 is not a solution. Finally, we have letter B. Notice you're going to add 3 to both sides. And then what you'll do next is you'll divide by 4. So the square root of 3x plus 4 equals 2. Oh, fourth root, sorry, my bad. Now you'll fourth power both sides because we want to undo that radical. So 3x plus 4 equals 16. We're going to subtract 4. So 3x equals 12 and divide by 3. So we do get x equals to 4. If we plug it into the original, the fourth root of 3 times 4 is 12 plus 4 is 16, which is 2. 2 times 4 is 8, minus 3 is 5, so it works. You're ready for practice, the end.